Welcome to Mobile Machine Learning for Android developers using TensorFlow Lite course. Tired of traditional Android development courses? Here is the next big thing. I am Mohammad Hamza Asif, Mobile Machine Learning instructor at Udemy. I have two more courses, but that is the most advanced and the exciting course of Mobile Machine Learning series. In this course, you are going to learn how to train machine learning models and use them inside your Android applications. You will also learn to use pre-trained machine learning models inside your Android applications. During the course, we are going to build 10 fully functional ML-based Android applications, and we are going to keep things simple so you will have a smooth transition from traditional to smart Android development. We will start by looking at the basic syntax of Python programming language. Then we will learn about some of the commonly used data science libraries. Then we will look at machine learning and deep learning. Then there will be a crash course on TensorFlow and TensorFlow Lite. Then we are going to practice all these things by training our machine learning models and developing Android applications for them. For our first application, we will keep things very simple by training a very basic model. Then we are going to develop Android application for that model. After that, we will work on a couple of exciting and interesting applications like predicting fuel efficiency of automobiles, recognizing handwritten digits, cats and dogs classification, rock, paper and scissors problem, recognizing different types of flowers, different kind of fruits, and different types of precious stones. During the course, you can test your learning by solving practice activities. In the first practice activity, you will train a model to predict fitness of a person based upon his height and weight. In the second practice activity, you will work on human and horses problem. So, the course contains a lot of exciting stuff, and you just need very basic knowledge of Android development to start. So, join me in this journey and have some skills that make you unique in the world full of Android developers.
Welcome to this lecture. In this lecture, we will download and install Anaconda Navigator. So, open your browser and type Anaconda distribution here. Now press enter, and now you need to find this link, which is individual edition Anaconda. So I'm gonna click on it. So you can directly type this link here, and here when you scroll down, you will see a download button. So just click on it. And now you need to choose the operating system. As I'm using Windows and my operating system is 64-bit, so I'm gonna download this installer, 64-bit graphical user installer. So I'm gonna click on it and the download will start. As I have already downloaded it, so I'm gonna cancel it. And now let's look at how to install it. So there is the Anaconda exe file that I downloaded. So now I'm gonna open it and now press the run button. Then next, I agree, just me. And now you need to choose the location where you want to install Anaconda. And the folder you choose should be empty. As I have already installed Anaconda, so my Anaconda 3 folder is not empty. So I'm gonna rename it to Anaconda 3.1 for example. Then press the next button. And after that, you just need to click this install button here. And the installation will be started. As I have already installed it, so I'm gonna cancel it. So now after the installation, you need to launch Anaconda. So here, search for Anaconda Navigator. And you will see an option Anaconda Navigator, so just click on it. So the Anaconda is launched successfully. So here you can see that there are several different types of software here. For example, Jupyter Lab, Jupyter Notebook, Spider and other. And we are gonna use Spider for training our machine learning models and developing Android application. So now we have installed Anaconda Navigator. The next step is installing TensorFlow inside Anaconda. And we are gonna do that inside next lecture. So see you in the next lecture.
Now we need to install TensorFlow inside our Anaconda Navigator. So in order to do it, we're gonna follow the instructions written on the official page of Anaconda TensorFlow. So here I'm gonna write TensorFlow Anaconda documentation. Or you can write TensorFlow Anaconda Windows. And now you need to click on the first link. So TensorFlow Anaconda documentation, click here, and here you will find the way to install TensorFlow inside Anaconda. So you just need to find Anaconda prompt. So just type Anaconda prompt or select Anaconda prompt here. So I'm going to open Anaconda prompt. And now you need to copy the lines and paste them inside Anaconda prompt. So the first command is conda create tf TensorFlow. So I'm going to copy this line and I'm going to paste it here inside our Anaconda prompt. So
Now press enter and you can see that I got a warning that Anaconda environment already exists. That is because I have already installed TensorFlow inside Anaconda, and in your case you will have a list of libraries which will be downloaded. So you need to press Y here in order to install all the libraries. So I'm also gonna press Y. So you will get a list similar to that the following libraries will be installed, like TensorFlow, TensorFlow Base, similarly VC and others. So here you need to also plus Y here, then these libraries will be downloaded and installed. So TensorFlow will also be installed. As for now, I'm gonna type no here because I have already installed them. Now the next step is executing this line, which is actually activating TensorFlow environment. So I'm gonna copy it and I'm gonna paste it here. So now just paste it and then press enter and your TensorFlow environment will be active. Now we need to test that whether TensorFlow is installed successfully or not. So you need to restart your Anaconda navigator if you have opened it. So I have already opened it, and now you can see that here you have applications on section. So we created a new environment which is an virtual environment. So the libraries which are installed in this virtual environment will not work for this base environment. So here you need to select the virtual environment. So I created virtual environment with the name TensorFlow environment. So I'm gonna select it. And now the software that you installed in that virtual environment will be visible. So most likely you will get an install button here for Spider. As I have already installed it, so I'm getting the launch button but for your case you will have an install button. So you will press this install button to install Spider. After that you will get a launch button, and now let's launch the Spider to test whether our TensorFlow is installed or not. So I'm gonna press on it and Spider will be opened in a moment. So the Spider is launched successfully. So that is the basic interface of Spider. So here we are gonna write our Python code and train our models and generate a TF-Lite file. So now let's test whether TensorFlow is installed or not. So I'm gonna type import TensorFlow as TF. And now you need to execute this line. So just select this line and press Ctrl plus enter. And now keep an eye on this window. So here you can see that we did not get any error. So our TensorFlow is installed successfully. So now let's check by printing the version of TensorFlow. So I'm gonna write print tf dot underscore version. So I'm gonna select it again and press enter, and you will see that we get 2.1.0. So my TensorFlow version is 2.1.0. So that is the basic interface of Spider. We're gonna write our code, then we're gonna select the lines we want to execute and press Ctrl plus enter. Similarly, the variable which we will create will be visible inside this variable explorer. For example, I'm gonna create a variable here. So v is equal to 10, and I'm gonna select this line and press Ctrl plus enter. You will see that now our variable explorer have a variable which is of type int, and its size is 1, and the value stored inside it is 10. So hopefully you will get the idea that how to install TensorFlow inside Anaconda and how to use Spider.
Welcome to this lecture. In this lecture, we will look at the basic interface of Jupyter Notebook. Jupyter Notebook is commonly used for writing Python code for machine learning and data science. So in order to launch it, open your Anaconda navigator, and here you can see Jupyter Notebook. Press this launch button and it will be opened inside a browser. It's because it's a web application, so you can open it inside any browser. Here you can create a Python notebook. So press this new button and choose Python 3, and it will create a Python notebook for you. So that is the basic interface of a Python notebook. Here you can write your Python code and execute it line by line. So if I type a variable a is equal to 10, now if I want to see value contained inside a, so just type a. Now if I want to execute these two lines, I can press this run button or this button on the left of this cell, and these two lines will be executed. So if I press this run button, you can see the value inside a is 10 and it will be printed here. Similarly, you can add comments and headings inside your code. So if you want to add a heading inside your code, you can simply choose the cell type as heading. Now if you write any text here, it will become heading. For example, head 1. Now if I press the run button, you will see that this text is more bold and highlighted, so it's a heading. Similarly, in order to add comments, just type a, for example, comment, and if you want to make this cell a comment, so just select this markdown option here, and now when you press the run button, it will become a comment, and this line will not be treated as a code cell. Similarly, you can add more cells by pressing on this add button, and more cells will be added. You can move up and down inside cell using these arrows. Currently I'm here. If I want to move up here, simply I can press on it, or I can use this arrow. So now you can see that I'm moving upward. Similarly, far down, press this button. So that is the basic interface of Jupyter Notebook. Here we will write our Python code. So see you in the next lecture. Welcome to this lecture. In this lecture, we will learn about the basic syntax of Python programming language. Python is a programming language which is being used by developers worldwide to develop various things like websites, machine learning algorithms, and automating day-to-day tasks. Basically, Python is a programming language that can be used for developing anything and everything you want. So let's begin. The best way to learn Python is to create your own separate notebook inside Jupyter Notebook and write the code line by line as I'm executing it. So firstly, we will learn about Python variables and data types. Python variables do not need explicit declaration to reserve memory space. It means that you do not need to specify the data type of a variable, and Python will automatically assign a data type based upon the value stored inside that variable. So for example, if I declare a variable v1 and store 5 inside it, now in order to check its type, pass it inside a type function. Now when I press this button to run these two lines, you will see the type of v1 is int, as Python automatically assigned it. So if I declare a variable v2 here and assign a 5.0, as you know that it's a float, so if I run it, you will see that its data type is float. So Python is automatically assigning values to these variables. Similarly, if I declare a v3 variable and store a string inside it, now if I run it, the data type is str, which is a string. Python has 5 standard data types: numbers, strings, list, tuple, and dictionaries. We will cover all these in this course. So firstly, we will look at Python numbers. As you can see, for example, if I declare a variable v1 and store 1 inside it, and if I declare another variable v2 and store 100 inside it, so if you want to see the value inside v2, so just type it and run these lines, and you will see that 1 is stored inside v1 and 100 is stored inside v2, and you are printing value for v2, which is 100, so it's printed here. Similarly, after declaring a variable, you can delete that variable to free that memory that it occupies. So in order to delete it, just type del and the variable name, and that variable will be deleted. Python supports 4 different numerical types. The first one is integer, second one is long, the third one is float, and the fourth one is complex. As we see the integer and float data type, now let's look at the complex data type. As you know that complex numbers have a real part and an imaginary part. Similarly, you can declare a complex variable here using the same mechanism. For example, if I declare a variable v3 here, so here 1 plus 3.14j. So 1 is the real part and 3.14 is the imaginary part. So if I check the data type of that variable by running it, you will see that complex is the data type of v3. Similarly, you can print the value inside v3 by pressing this button, and now the value inside v3 is 1 plus 3.14j, so it's a complex number. Now let's look at Python strings. You can declare a string by typing a variable name =, then specifying the value inside a single quotation or double quotation. So I declared a variable str and stored hello world inside it. Now if I want to print it, so you can just type str, or you can use the print function and type the print str. So now when I run it, you will see that it printed hello world here, and as I printed 6 lines, the result of all these 6 lines is printed here. So now let's try to understand it. So in the second line, you can see that if you want to print the alphabet at the particular index, you can use this string variable and use the square brackets and type the index you want to print. So if I want to print the first character, so 0 is the index, as you can see that h is printed here. Similarly, if you want to print multiple characters inside a string, for example, if I want to print characters starting from second index till the fourth index, you can specify it like that. So if I want to print second index element, so start with 2, and if I want to print two more elements, so which is the third and the fourth index, so just type 5 here, as 5 is exclusive, so it will print values starting from 2 till 4, and if I specify 6 here, it will print values starting from 2 till 5. So now as the value at the second index is L, and similarly the third index is similarly L, and the fourth index is O, so you can see that it printed double LO here. Similarly, if you want to print values starting from a particular index, so if I want to print values starting from 2 and onward, so you can specify it like that. You can square brackets 2 and similarly the colon sign here, and it will print values starting from that index till the end of that string. So as you can see that it printed that line here. Now if you multiply a string with a 2, it will print it 2 times, because if it's a hello word stored inside str, and when you multiply it, it will automatically repeat that value, and you can see that here hello word and hello word is printed. Now you can concatenate a string using plus operator, so str plus test. Now you print it, you will see that hello world test is printed here. So that is the basic operations you can perform on Python string. There are a lot more and you can explore them over. Now let's look at Python list data structure. List is most versatile of Python compound data type. A list contains items separated by comma and enclosed within square brackets. So how we can create a list in Python? Just name the list, then equal sign, then within square bracket you can specify the elements of list. Here I created a list where first element is 10, second one is a string which is hello, third one is 20, and fourth one is a float value which is 30. As you can see that list contain items of different data types. Even a list can contain element which is a list itself. Now if you want to access element present at particular index, you can use the same approach you use with arrays in Android or Java. So now let's run this line and our list will be created. After that, run this line and element present at the 0th index is printed, which is 10 here. Similarly, you can check the data type of element of list, and here first element is of integer type, second element is of string type. And if you want to access multiple elements, you can use that colon approach. Here if I want to access element present at index 1 and 2, I can use this colon approach, that 1 till 3, and 3 is exclusive here, so it will print values present at index 1 and 2. Now run this line and you will see that hello and 20 will be printed. Similarly, if you want to change the value present at particular index, you can change it by assigning a new value at that index. Now run this line and it will place value 100 at index 2. Now if we print value present at index 2, then it's not 20, it's 100 now. Similarly, you can print the whole list and you will see that items present are 10, hello, 100 and 20 and 30. Now let's look at commonly used list method. Append is the method used to add element at the end of list. If I want to add 1 at the end of list, I can use list.append and specify 1 here. When I run these lines, you will see that 1 is added at the end of list. Similarly, if you want to add multiple elements at once inside a list, you can use this plus operator approach. So here I specify list plus equal to 2, 3 inside square bracket. Now when I run this line, you will see that 2 and 3 are added at the end of list. So this plus operator is quite useful for adding multiple elements inside a list. Now let's declare a new list. Now this list contains element 1, 2, 3, 4, 5 and 2, and count method is another useful method to get count of particular element. So if I want to check that how many times 2 is occurred inside a list, I can use this method list.count and specify 2 here, and when I run this line, you will see that it returned me 2, that it means that 2 occurs 2 times inside that list. Now the index method is used to get the index of particular element inside a list. So if I want to check the index of 2, I run it, you will see that it returned me 1. It means that 2 is present at the index 1 inside the list. Similarly, insert method is used to insert element at particular index. If I want to add 111 at the index 3, I can use this method and when I run these lines, you will see that 111 is added at the index 3. Similarly, you can remove element using remove method and specify the element you want to remove, and now that 111 is removed from list. Reverse method or sort method are another useful methods for list. Here, if you want to sort an elements of list, you can use list.sort, and elements will be sorted in ascending order. As you can see that elements are sorted. Similarly, you can reverse the list using reverse method. Now all the elements are reversed and 5 is present at the first index, but previously it was present at the last index of list. Now let's look at Python tuple data type. A tuple is another sequence data type that is similar to list. A tuple consists of number of values separated by commas and closed within parentheses. The major difference between list and tuple is that once assigned, you cannot change the value present at particular index of a tuple. So, if you don't need to change data inside a list, you better make it a tuple because it's very fast. So how we can declare a tuple inside Python? So just name the tuple equal sign, and within parentheses you specify the element of tuple. So here you can see that I defined a tuple here. Now in order to access value present at a particular index, use the square bracket method. So if I run this line, now by running this line you will see that the element present at the index 0 will be printed, which is 10. Now if I try to reassign the value, it will give me an error that object does not support item assignment. So once assigned, you cannot change the value present at particular index of a tuple, but they are very fast. Now let's look at Python dictionary data structure. Dictionary work on the concepts of key value pair. For each value you have a unique key associated to it. So inside a Python, if you want to declare a dictionary, just name the dictionary equal sign, then within curly braces you specify the key, then colon, then the value for that key. Then similarly, by separating them with commas, you can specify as many key value pairs as you want. Now let's run this line. Now our dictionary is created. Now if you want to get the value for particular key, you can use this square brackets and specify the key here, and the value will be printed. Now as you can see that the value for key k1 is 1, so it is printed here. Now let's look at conditional statements inside Python. They are quite similar to any other programming language. So I specified two variables v1 and v2 here. So if v1 is greater than v2, print v1 is greater. The change here is that instead of using else if, they shortened it to elif. So I specified the second condition that v2 is greater than v1, then print v2 is greater. Similarly, else v1 is equal to v2. So if I run it, you will see that v1 is greater is printed. As when I change the value to 8, now v1 and v2 are equal. Now it will gonna print v1 is equal to v2. Now let's look at the loops inside Python. There are mainly two types of loop, while loop and for loop. While loop is quite similar to the Java while loop. Here I declared a variable count, then inside while loop I specified the condition, then I printed the value stored in that variable. Then I incremented that variable. So if I run it, you will see that value will be printed for each iteration of the loop. Now let's look at the for loop. For loop is used with quite frequently with lists. For example, if I want to print all the element of that list, I can use for v in list print v. Now what it will gonna do, it will take each value inside that list one by one in that variable v, then we can use this variable v. So if I run it, you will see that all elements of list will be printed one by one. Now you can run it on a string object as well. For v in Python print v, then each character will be printed on a separate line. So that is the basic syntax of for loop inside Python. Now if you want to take input from user, you can use the input function. So here you specify the string you want to print along with the input bar. So here I specify input enter your name. So if I run it, you will see that it will ask user to enter his name. So I enter it, Hamza. Now when I press the enter, you will see that my name Hamza is printed here as I printed it after that statement. So that's how you can take input from user in Python. Now let's look at file handling inside Python. In Python, while opening file, you need to specify the file name and the mode in which you want to open. For reading purpose, use mode R, and for writing, use mode W. Similarly, for reading or writing file in binary format, use WB and RB, and for appending an existing file, use mode A. Now let's open a file a.txt, and here we specify the mode W. So it will create a file a.txt and open it in a writing mode. Now let's run this line. Now in order to check that whether this file is open or closed, you can use f.close. Now if I run it, it will return me false. It means that this file is currently open. Now if let's close this file using f.close function. Now let's run this line. Now f.close will return true. It means that now this file is closed and we cannot write in that file. Now let's see how we can read or write file in Python. Let's open a file intro.txt in writing mode. I created a variable str1 and store python is fun inside it. Now let's write this variable inside that file using f.write function. Now if I run it, it will create a file intro.txt and store python is fun inside it. Now let's read it from that file. Using open function, I specify the mode R. Now we are opening that file for reading purpose, and using f.read function, I specify the number of characters I want to read from that file. Now I printed the variable value. Now let's run it, and you will see that python is fun is printed here. So it read the value, the 13 characters from that file, then I printed that value. If I change it to 3, now you will see that when I run it, you will see that it only printed first 3 characters. So we are writing and reading from a file inside Python. So that's how you can read or write a file in Python. The main thing here is the mode in which you are opening a file. Welcome to this lecture. In this lecture, we will learn about one of the famous libraries used for computation in machine learning and data science, and that library is NumPy. NumPy is a library for Python programming language, adding support for large multidimensional arrays and matrices. It provides a large variety of functions to work with these arrays. So, in order to use NumPy, you firstly need to import it. So, using import NumPy as NP, we will import NumPy. Here, NP is the alias. Instead of using whole NumPy word, we will use NP to get access to the functions of NumPy. So, let's run this line, and this library will be imported. Now, in order to create an NP array, use np.array function, and here inside curly braces, you will specify the elements that array will contain. Now, let's run it, and it will create array. Now let's see some features of this array. Now if I run it, you will see that firstly I printed that array, so that array contains 1 and 2. Then I printed the type of that array, and the type of whole array is numpy.ndArray. And here then I printed the shape, and shape is 2, 1, and here finally the size, which will be the number of elements that array contain, and it's 2, as array contain only 2 elements. Now let's create a 2D array using np.array function, and here I specified element 1, 2 and 3, 4. Now if I run it, it will create a 2D array. Now we will see the same features for this 2D array. Now you will see that firstly I printed that array, then the type of array is ndArray. Similarly, the shape is 2, 2, and the size is 4, as it contains 4 elements. Then at the end I printed the data type of the first element of that array, and that data type is integer. So by default, if when we created this array, as we specify integer here, so the data type of all the elements is integer. You can specify explicitly the data type by using dtype parameter. Here we use np.array, and here I created that array. Then I specify dtype is equal to np.float32. Now the data type of all the elements of the array will be float. Now let's compile these lines, and now this array will be created, and here you can see the type of the first element of this array is float. Now so you can explicitly specify the data type of variables that array will contain. Now let's look at some of the built-in functions of NumPy library. The first one is np.zeros. np.zeros will create a matrix filled with 0. So if I want to create a 4x4 matrix where each value is 0, I will use np.zeros, and here inside parentheses I will specify the shape of the array, which is 4x4. So if I run it, you will see that it created a matrix where each value is 0. Now if you want to create a matrix where each value is 1, you can use np.1, and here you will specify the value, the shape of the array. So if I run it, you will see that it will create a 2D array where each value is 1. Similarly, if you want to create an array which is filled with random values, you can use np.random.random, and here you will specify the shape of that array. Now if I run it, you will see that it will create a 4x4 array where each value is generated randomly. Similarly, if you want to specify the value that each index should contain, you can use np.full function, and here you first specify the shape of the array, then comma, then you will specify the value you want at each index. So if I run it, you will see that now it created a 4x4 array where each value is 6. Now once you created an array, you can reshape it. As I created a 4x4 array filled with 6, now I can reshape it into a 3D array. Now if I run it, it will transform this array from 4x4 to 2x2x4. Now, if you want to create a 1D array from 2D array, you can use the flatten function of NumPy library. So if I created a np_random.random and I created an array with 2 rows and 4 columns, now if I run it, you will see that array I created. Now if I want to convert it into a 1D array, I will use an array.flatten function, and it will generate a 1D array from this 2D array. Now you can see that it converted this 2x4 array into 1x8 array. Now let's look at some of the operators we can apply on NumPy arrays. So firstly we will look at unary operators. So firstly we created an array, np.array will create an array for us. Now array.min will return us the minimum value contained inside this array. Similarly array.max will return the maximum value, and array.sum will sum all the elements and return us the result. So if I run it, as you can see, the minimum element is 1, the maximum element is 6, and the sum of all these elements is 21. Now let's look at some of the binary operators. So I created two np arrays using np.array function. Now we can sum these two arrays using plus operator, multiply them using multiplication operator. Similarly, we can take dot product using dot function. Now if I run it, so that is the result of sum of these two arrays, and that is the result of multiplication of these two arrays, and that is the result of dot product. Similarly, if you have 2D arrays, which are basically matrices, you can apply matrix operations like matrix multiplication. So I created two 2D arrays, m1 and m2. Then using np.matmul, I will multiply these two matrices, and it will give me the results. So that is the result of multiplication of these two matrices. Similarly, you can sort the elements of array using np.sort function. So I created an array that contains random values, and the shape is 4x3. Now that is my array. Now if I want to sort the elements of this array, I will use np.sort, and here you can specify the axis. If you specify the axis 1, it will sort the array row wise. Similarly, if you specify the axis 0, it will sort the array column wise. So if I run it, so now you can see that it contains the minimum value, and here it contains the maximum value. Similarly, for each row, the minimum value is here and the maximum value is here. So it sorted my array row wise. Similarly, if you want to sort them column wise, you will use np.sort and axis is equal to 0. Now you can see that the minimum value is here and the maximum value is here. Similarly, for that column, minimum value is there and the maximum value is there. Similarly, for that column, minimum value is there and the maximum value is at the bottom right of the array. So that is the sort function. Here you need to remember one thing. If you want to sort the array row wise, you need to specify x is 1, and if you want to sort the array column wise, you need to specify x is equal to 0.
Welcome to this lecture. In this lecture, we will look at a library named Pandas. Pandas is a famous library in Python used for data manipulation and analysis. There is mainly one thing inside Pandas, and that is Pandas data frame. It's a two-dimensional tabular data structure. So how we can use Pandas inside Python? Firstly, we need to import it. So import Pandas as PD, like we import NumPy as NP. Now we also need to import NumPy. We will use later in this lecture. Now if I run this line, these libraries will be imported. Now let's create a simple Pandas data frame. So firstly we will create an array. So that array contains 10, 100 and 1000. Now using pd.dataFrame function, we will convert this array into a Pandas data frame, which is a tabular data structure. So if I run it, you will see that now this
array is converted into a tabular form, that is the index and that is the value. So now we can also create data frame from dictionary, and dictionary is quite useful because we can name each column using the dictionary. For example, if I create a dictionary, so here my first key is the name and the value is a list. Similarly, my second key is the age and the values is a list of values. Now using pd.dataFrame function, here I will pass this dictionary. Now if I run it, you will see that it created a table for us. Here our first column is the name and the second column is age. Similarly, that is our index. Similarly, you can use Pandas to read the CSV files. CSV files are comma separated values. For example, that is the example of a CSV file. Here you can see that values and you usually view them inside Microsoft Excel. Now if I want to read this CSV file inside my code using pandas library, so I will use pandas.read CSV function, and here I will specify the path where my file is placed inside my computer. Now here I specify the index column as well. Index column will be the column which will be used as index. So for example, if I use a team column as index, so if I run it, now you will see that all my other columns, name, number, position, age, are there, but the team column is here. So this team column will be used as index. So if I change it to name column, you will see that if I change it to name, now if I rerun it, now you will see that our index column is name and it's here. So you can read large data sets which are present in CSV file using pandas. Similarly, you can read all other tabular data which is placed either in a text file or placed inside a web page using pandas.readTable function. Now if you have your data inside text files or on a web page, you can use pandas.readTable function to read that. For example, if I have my data here inside that text file, as you can see that here the first column is name and the second is age. Similarly, below that are the values. So if I want to read that text file in tabular form, I will use pandas.readTable function, and here I will specify the file name, and secondly I will specify the separator. Separator is the value using which the values are separated inside my text file. So in my case it's a single space, so separator is a single space. Now if I run this line, you will see that it will read the data inside my text file in tabular form. So it's actually a data frame. Now the first column is name and the second is age. Now when you have data, you sometimes have missing values. Missing values are like you have no value at some place. So let's firstly generate a data set with some missing values, then we will handle it. So firstly I created a dictionary, and here is the first key is first score, and the values is a list which are 190 np.nan. Here np.nan is a missing value. It stands for not a number. So when I read it as a data frame using pandas.dataFrame function and display it, you will see that here in the third column there is a nan value. Similarly, here in the third row there is also a nan value. So using dataFrame.isNull function, we can see where the null value is present. As you can see that here it returns me true because there is a nan value. Similarly, here it also returns me true in the third row because it also contains a nan value. So if we want to replace this nan value with some specific value, we can use df.fillNow function, and here we will specify the value with which we want to replace this nan value. I want to replace it with 0, so if I run it, now you can see that now it contains 0 where it previously have nan values. So similarly, you can check the shape of your data frame using df.shape, and in my case the shape is 4x3 as it contains 4 rows and 3 columns. Now you can also drop the rows which contain null values. So using df.drop now, it will drop all the rows that contain null values. So as you can see that only my second row does not contain any null value, so it will not drop it, and it will drop all other 3 rows. So that is the df.drop now function. Welcome to this lecture. In this lecture we will look at our visualization library, and that library is Matplotlib. Matplotlib is an amazing visualization library in Python for the plots of 2D arrays. So in order to use it, we firstly need to import it. So import matplotlib.pyplot as plt. So now instead of using whole this word matplotlib.pyplot, we will use plt to get access to the functions of matplotlib. So as matplotlib is used to draw the graphs of arrays, so firstly we create two arrays. Here x contain 10, 20 and 30 and y contain 3, 2, 1. Now we will use plt.plot function and pass x and y here. Now firstly if I run this line, this library will be imported. Now if I run it, you will see that it will create a plot for our arrays. Here x-axis is for this x array and y-axis is for this y array. Now you can see that this is a line plot here. Now you can also plot a bar plot which will show the bars. If I run this line, you will see that now it printed bars here. Similarly, now x is still on the x-axis and y is along the y-axis. Similarly, scatter plot will print the dots for us. As you can see that now it printed a dot for us, that when x is 10, then the value of y is 3. Similarly, when the x is 20, the value of y is around 2. As you saw that how we can plot graphs of arrays using Matplotlib. Similarly, we can work with images using Matplotlib. So in order to work with images, we firstly need to import matplotlib.image and we will import it as im. So now using im.imRead function, and here we will specify the path of image we want to show. Now plt.imShow, and here we will pass this variable and this image will be displayed. So firstly I import this. Now when I run it, you will see that our image is plotted here. Now image is actually a multi-dimensional array. So when I want to see the shape of this image, so img.shape will give me the shape. So it's a 400 by 900 by 3. So it's actually a 400 rows and 900 columns, and each cell of this image contains 3 values. So now when I print this image, you will see that it's actually a multi-dimensional array, and here there is a value placed at each index. Similarly, I can access the value present at one particular index using the same square brackets and index method. So when I run it, you will see that it returned me 1. So value present at this index, 0th row, 0th column and 0th index of the third dimensional is 1. So images are basically multi-dimensional arrays, and we will treat them same like we treat multi-dimensional arrays, and we perform computations on them similarly.
Welcome to this lecture. In this lecture, we will start learning about machine learning. So what is machine learning? Machine learning is a set of rules that computer develop on its own to solve problems. The basic idea is that you supply data to computer and computer find patterns in that data, and the data could be in the form of shapes, numbers, images or any other format. So now let's look at the key terms we are gonna use this lecture. So now let's look at some of the key terms used in machine learning. So the first one is dataset. So what is dataset? As the name suggests, it's actually a collection of data. So now let's look at a very simple dataset. So here we have height, weight and gender of 4 different persons. So for the first person, height is 6 feet 1 inch and the weight is 55 kg and the gender is female. Similarly, for the second person, height is 4 feet 6 inch and the weight is 65 kg and the gender is male. Similarly for other 2 rows. So that is called a dataset. So the next term is training data and the testing data. So what is training data? In machine learning, we train our machine learning model on data, and the data on which we train the model is called training data. So for example, we have 4 rows. We will keep 2 for training and 2 for testing. So we will train our machine learning model on this training data, then we are going to test the machine learning model on this testing data. So the other data set here is testing data, so we keep 2 rows for training and 2 for testing. But in usual, we will keep more rows or more data set for training than as compared to testing. Now the next term is feature and label. So what is label? Label is the value we are actually predicting. So for example, in our case, we are predicting gender of person based upon his height and weight. So if person weight is 55 kg and the height is 6 feet 1 inch, its gender is female. Similarly, we have other values. So we are predicting the gender, so our label is
gender. Similarly, what are features? Features are the values with the help of which we are predicting gender. So we are using height and weight to predict gender of person. So height and weight are features and the gender is the label. So hopefully you will get the idea that what is feature and what is label. Now let's look at the types of machine learning. There are three types of machine learning: supervised machine learning, unsupervised machine learning, and reinforcement learning. Now let's quickly go through them. So the first type is supervised machine learning. In supervised machine learning, we use label data to predict a label given some feature. It means that we train model on questions and also answers of those questions. Then we ask model to give answers of similar questions. So now let's understand supervised machine learning with an example. Suppose that we have the same data set that we previously discussed. So we have height of person, weight of person, and its gender. So here the label is gender and the features are height and weight. So we are predicting this gender. We also have the value for this gender. So it's a label data because we have the value for the label. So if we only given height and weight, not the gender, and we ask to categorize the person based upon their height and weight, then it's unlabeled data. And that is not supervised machine learning. In supervised machine learning, we are also given features and labels. So we have height and weight here, which are the features, and the gender is label. So that's a very basic example of supervised machine learning dataset. So now we want to perform the training of model. So we are going to train the model on our training data, then we are going to test it on testing data. So we will give the model that the height of person is 6 feet 1 inch and the weight is 55 kg and the gender is female. Similarly, the height is 4 feet 6 inch and the weight is 65 kg and the gender of person is male. Similarly, we will give the data of thousands of person to train our machine learning model. After the training, we are only going to give the height of person and the weight of person. Then we are going to ask the model what is the gender of person. So that is supervised machine learning, that we give questions along with the answers for training. Then we will only ask the questions that what is the gender of person. So hopefully you will get the idea of supervised machine learning. Now let's look at classification and regression problem. If the label we are predicting is continuous, it's called a regression problem. If the label is categorical, then it's called a classification problem. So what is continuous label and categorical label? For example, we are predicting gender of person. So gender can have either two values, which is male and female. So it's a categorical label. So our label is categorical and this problem is classification problem. If you are predicting fuel efficiency of automobile, so it can have any value like 20 miles per gallon, 21 miles per gallon, 30 miles per gallon, and so on. So this problem is continuous because our label is fuel efficiency of automobile, which is a continuous value as it can have any value. So this problem is a regression problem. So hopefully you will get the idea that what is regression problem and that what is classification problem. So now let's look at the classification problem in detail. As previously discussed, in classification problem we are predicting classes or categorical label. So for our example, we have height and weight of person and we are predicting gender of person. So our task is given a person height and weight, predict the gender of person, which is either male or female. So here our label is categorical, so it's a classification problem. As it's supervised machine learning, we will have both height and weight of person along with their gender for training. Then we will test our model by only giving height and weight to it and checking whether our model predicts the gender right or wrong. So that's a classification problem and it's a supervised machine learning problem. Now let's look at the regression problem. Suppose that we are training model to predict house price. So we have features like area of house and the number of rooms, and our label is house price. Here house price can have any value like $300, $10,000 or any other value. So it's a regression problem. So our task is given a house size and number of rooms, predict the selling price. So here our label is continuous value as it can have any value, so it's a regression problem. As it's supervised machine learning, we will have house size and number of rooms of house along with their price for training. Then we will test our model by only giving house size and the number of room and check whether the model predicted the house price right or not. So that's a regression problem. So these two are the major problems inside supervised machine learning.
The second type of machine learning is unsupervised machine learning. Our data is not labeled in unsupervised machine learning. Unlike supervised learning, we don't have a resultant value. We just give input data and we need to find patterns in that data. We give that unlabeled data to model to train it, then we ask questions from the model. One of the techniques using unsupervised machine learning is clustering. In clustering, we form clusters of related data. For example, we have a data set similar to our previous data set. So we have height and weight of person, but we don't have gender here. Now we will apply some machine learning techniques to form clusters of related data. So we will train our model on this data set, and after training, it will form some clusters or different categories of data that each will classify each data set in a certain category. Then we will give some points for testing and see that in which cluster or in which group it will gonna put the person for which we are performing the testing. So that is unsupervised machine learning, that we don't have a labeled data. Now the third type of machine learning is reinforcement learning, and this learning is using trial and error method. We will perform an action and depending upon result learn whether an action is right or wrong. And the example of reinforcement learning is robotic dogs, self-driving cars and others. Welcome to this lecture. In this lecture, we will start learning about deep learning. Deep learning is a subfield of machine learning inspired from biological neural networks. In deep learning, we feed our data to neural networks for training. A neural network has layers and each layer contains different neurons. If you are not familiar with neural networks and deep learning, these things are new for you, but with time you will get familiar with them, as in the next lecture we are going to cover a very good example that will give you the complete understanding of working of neural networks. Now let's look at basic structure of neural network. So that's how a neural network look like. Here each circle is representing a neuron. A neuron receives multiple inputs and it generates a single output. For example, this circle is taking these two inputs and it's generating a single output which will be passed to this neuron and this neuron. So the output generated by this neuron will be same for these two neurons, but the inputs will be different. So it's getting a different inputs and it's generating a same output for the output neurons. So as I discussed that neural network consists of layers, so there are three types of layer in a neural network. The first one is input layer. So for our case, these blue neurons are representing the input layer. For example, in our previous example where we are using height and weight to predict gender of person, we will pass height and weight to these two neurons. For example, we will pass the height to the top neuron and the weight to the bottom neuron. So we are passing input values to the input layer neurons. Then the second type of layer is the hidden layer. So that's the hidden layer. Here pattern finding is done. As in the machine learning, we are actually finding patterns in our data. So in the hidden layer, pattern is being explored in the data, which is passed in the input layer. So there can be multiple hidden layers in the neural network. Similarly, the third type of layer is output layer. Here the outputs are generated. So for our heights and weight example, where we are predicting either a person is male or female, we will get two values here. We will get 0 for male and 1 for female. So these output neurons are containing the output for our network. So if this neuron is representing a male and this is representing female, so if we get a larger value for male neuron, then the output will be male. Similarly, if we get a larger value for this female neuron, then the output will be female for that data. So hopefully you will get the idea that input is passed to the input layer, then the pattern finding is done in the hidden layers, then we get our output at the output layers.
Let's understand working of neural networks through an example. As in classification example of previous lecture, we want to predict gender of person based on height and weight. So our dataset will look like this. We have three columns in our dataset. First one is height, second one is weight, and the third one is the gender. So height and weight will be the features and gender is the label that our model will predict. In the first row of dataset, height is 100 and weight is 56 and gender of person P1 is male. So height and weight will be the input of neural network. So we feed our input data in the input layer neurons. So we feed height here in the first neuron and weight in the second neuron. Each line between these neurons represent a weight and is changed while training, and it is used to determine the value of neuron in the next layer. So now we need to find value of neurons in the next layer. We populated these weights with imaginary values for now. So our task is to find value of neuron Z1, Z2 and Z3. So value of neuron in the next layer is calculated using value of neuron in the previous layer. So in order to find value of Z1, we need to find neurons in the previous layer that are connected to it, which are these two neurons. So how we find value of Z1? For that purpose, multiply the value of neuron in the previous layer that is connected to it, which is 100, with the weight of the line that connects them, which is 0.1. Then add the value of neuron in the previous layer, other neuron in the previous layer, which is 86 multiplied by the weight 0.2. Then we add them and take sigmoid, and the resultant value is 0.42. So the value of neuron Z1 is 0.42. So what is sigmoid here? Sigmoid is the activation function, and it will give result between 0 and 1, and formula for the sigmoid is 1 over 1 plus e power minus x. You can learn about activation function in detail, but in this course we will not cover them in more detail. There are other activation functions as well other than sigmoid. So now we need to find value of neuron Z2, which will be found using same formula. So multiply the value of neuron in the previous layer, which is 100, with the weight and then add the value of other neuron and multiply with the weight 0.4, and then add them and take sigmoid. So the resultant value is 0.68. Now we need to find the value of neuron Z3, which is calculated using the same formula. So multiply 100 with 0.1, then add 86, and then after that add 86 multiplied by 0.6, then take sigmoid, and the resultant value is 0.51. Now we calculated values of neuron in the hidden layer. Now our task is to find the resultant value or the value of neurons in the output layer. So similarly, we apply same process to calculate value of output layer neurons, which are y1 and y2. So y1 will be equal to value of neuron in the previous layer, which is 0.42 multiplied by 0.3, then the value of other neuron 0.68 multiplied by the weight 0.2, and the value of third neuron in the previous layer 0.51 multiplied by 0.1 multiplied by 0.2. Then we take sigmoid, and our result is 0.46 for y1. Similarly, we calculate value for y2, and that value is 0.54. So what does that mean? So value of neuron y1 and y2, we calculated value of output layer neurons. So let's say we are representing male by 0 and female by 1. So now our model is saying that the weight and height we put in the input layer is of a female, as we are representing female by 1. So value of neuron y2 is greater, so it means that there is 1 there and there is 0 there. So y1, if the value of y1 is greater, then we are saying it's a man, and if the value of y2 is greater, then we are saying it's a female. So now, right now our model predicting that weight and height of person is of a female. This whole process is known as feed forwarding. So what is feed forwarding? Feed forwarding is putting our data at the input layer, then calculating the value of neurons in the next hidden layers, then finally calculating value of neurons in the output layer. That process is known as feed forwarding. Right now our model is not predicting right, as the height and weight of person we submitted are of male, but our model is saying that it's a female. It's okay, because we did not update the weights, or we did not actually train our model. So now we got values for both y1 and y2. The value for y2 is close to 1 as compared to y1. So person is female according to our model. But it's a training process, and we know correct value for person P1. So now we will update weights so that our model will produce more accurate result next time. This process is known backpropagation. Backpropagation is updating weights based upon actual result and predicted result while training. Now all of these weights will be updated and model is trained on whole dataset again. This process is repeated again and again so that model will learn how weights and heights are affected by gender. As our model did not predicted the correct gender first time because it's not trained. Now we will update these weights. The weights of lines that connects these neurons based upon actual result, which is male, and predicted result, female. Now we update these weights and then again we will perform the whole process of feed forwarding so that and then we will again check the predicted result and the actual result and again update these weights, and this one complete sample is known as epoch. So we train our model for several different cycles depending upon the complexity of our data. So the process of updating these weights based upon actual result or predicted result is called backpropagation. So what we learn, feed forwarding, which is actually putting our data at the input layer, then calculating value of neurons in the hidden layer, then finally calculating value of neurons at the output layer. That is feed forwarding. Then based upon predicted result and actual result, we will update these weights. And this process is known as backpropagation. So that is actually the whole process of neural network, simple neural network. So let's review all this. Deep learning is usually using neural networks for training. What we do, we feed our input data at the input layer. Data is multiplied with weight and the value of neuron at the next layer is calculated. Similarly, value of output layer neurons are generated. This process is known as feed forwarding. Then weights are updated based upon actual result and predicted result. This process is known as backpropagation. This process is repeated again and again to train neurons. The purpose of this demonstration is to give you basic understanding of neural network. I'm skipping a lot of tricky stuff to maintain your interest. If someone wants to learn more, he can search about backpropagation, activation functions, learning rate, L1, L2 regularization, and feed forwarding. Welcome to this lecture. In this lecture, we will revise some previous concepts and learn some new ones. So let's start. Firstly, we learned about machine learning, that machine learning is finding pattern in our data. Then we studied the types of machine learning, and the first one was supervised machine learning, which is training model on labeled data. Both input and desired output are provided to model for training. Then we studied about unsupervised machine learning, which is training model on unlabeled data. Only input data is provided for training, and our model is responsible for finding pattern in that data. Then we studied about deep learning, which is basically using neural networks to train our model. So what actually was a neural network? Neural network is a network that contains layers of neurons. Then in deep learning we studied about feed forwarding. So what actually was feed forwarding? Feed forwarding was giving input data at the input layer neurons, then calculating values of neurons in the hidden layers, then finally calculating the values of neurons in the output layer. And this whole process is known as feed forwarding. As you can see that process started at the input layer and proceeds towards the output layer. So it's also known as forward pass. Then we studied about backpropagation. So what is actually backpropagation? When in the feed forwarding we calculated the predicted labels, then we compare the predicted results with the actual results. Then we will update these weights, and this process is known as backpropagation. So we have value for y1 and y2, then we will compare these results with the actual results, then the values of these weights will be updated. Then after that the values of these weights will be updated. As you can see that process also propagates from output layer to input layer, so it's known as back propagation. As it's moving towards input layer from output layer, so it's also known as backward pass. Then activation function. Activation function determines the output a node will generate based upon its input. In deep learning, the activation function is set at the layer level and applies to all neurons in that layer. So, as you see in the previous lecture, we applied activation function after calculating the value of neuron, so that we will get a value in a specific range. There are several other activation functions as well other than sigmoid, which are ReLU, softmax, softsine, tan, hyperbolic. Now, learning rate. So what actually is learning rate? Learning rate, the amount that weights are updating while backpropagation is referred as learning rate. So while backpropagation, when the weights are updated, learning rate is used to control that how much these weights are updated. And you have to determine the value of learning rate by trial and error. You will try different values for learning rate and then you will see the accuracy of your model. So it's called a hyperparameter. Then loss function. Loss function tell us how different our predicted results are from the actual results. In order to monitor error of neural network while training, loss function is used. Then weights are updated, so the value of loss function will reduce in the next epoch while training. So loss function tell us that how different our results are from the actual results. So if our model is not predicting the right results, then the value of loss function will be greater. But if our model is accurate, then the value of loss function is very small. As we studied the loss function in the previous lecture, the next thing is optimizer. Optimizers are used to find minimum of a function. As our goal is to find minimum value of loss function so that our predicted results and the actual results are alike. So optimizer will do that for us. There are different optimizers like Adam optimizer, adaptive caustic gradient descent method, and there are others as well. And the next thing is overfitting. If our model performs well on the training data but not that good on the test data, that is called overfitting. It's because our model will start remembering data instead of finding pattern in our data. So while training, we supply the training dataset, then we supply the test dataset to evaluate our model. So if the results of test dataset are not that good as the results of training dataset, then it's overfitting. And it occurs because our model is unable to find pattern in our data. Instead of that, he started remembering data. So when we supply the test dataset, he will not perform well on that dataset. There are several techniques to avoid overfitting, and one of them is dropout. Dropout is a technique to avoid overfitting. Dropout refers to ignoring units or neuron while training. So by ignoring, I means that these units are not considered during a particular forward or backward pass. So when we are training our model, for example, we have 10 features. So while training, we ignore some features in a certain epoch, and the features we carry during that epoch are determined randomly. So we don't supply all the features in a single epoch. We supply different number of neurons or features in the different epochs. So by doing that, our model will not overfit. And as the name suggests, dropout, we are actually dropping out some neurons while training process. So the next thing is normalization. Normalization is a technique often applied as part of data preparation for machine learning. The goal of normalization is to change the value of numeric columns in the dataset to a common scale without distorting differences in the ranges of values. For machine learning, every dataset does not require normalization. It is required only when the features have different ranges. So let's try to understand normalization through an example. Consider a dataset containing two features, age and income, where age ranges from 0 to 100 while income ranges from 0 to 20,000 and higher. Income is about 1,000 times larger than age, and it ranges from 20,000 to 5 lakh. So these two features are in very different ranges. So when we do further analysis, the attributed income will intrinsically influence the result more due to its larger value. But this does not necessarily mean that it is more important as a predictor. So while we have columns in our dataset that have different ranges, for example, one value ranges from 0 to 100 and other ranges from 20,000 to 5 lakh. The column where values are larger have more influence on the result. So in order to avoid that, we do normalization. We perform operation on these datasets so that they have a common scale. So one way to normalize is to divide income by maximum income. So for example, our maximum income is 5 lakhs. So we divide all the incomes by 5 lakhs. So this will give us a result between 0 and 1. And similarly, we divide age by maximum age. So for example, the maximum age is 90. So we divide all the ages by 90. So all the ages will have now value between 0 and 1. So now both income and ages have value in the same scale. So now the income will not influence our results. Now both ages and income will have values between 0 and 1. So that is normalization. We change the scale of our values. There are several other normalization techniques as well, which are, for example, and one of them is to use mean and standard deviation. We subtract the mean from our data and divide it with the standard deviation of that data. So it will also normalize our data. So that is normalization. Welcome to this lecture. In this lecture, we will learn about TensorFlow. TensorFlow is an open source software library developed by Google in 2015. It is one of the famous libraries used for numerical computations and large-scale machine learning. It makes it easier for developers to design, build, and train deep learning models. Further, it has a TensorFlow Lite module which will enable developers to run machine learning models on Android. So let's learn about it. So in order to use TensorFlow, we firstly need to import it. So import TensorFlow as TF. Now if you want to check the TensorFlow version, simply use tf.version and it will print TensorFlow version. So if I run it, you will see that it will print the TensorFlow version, which is currently 2.0. Now there is something new inside TensorFlow 2.0. Previously in TensorFlow, expressions are not evaluated directly. Instead, computation graphs are generated and these graphs are evaluated inside session. But now there is eager execution, which means expressions are evaluated immediately and concrete values are returned. So previously expressions are not evaluated directly. Instead, computation graphs were constructed and they were evaluated later inside session. But now expressions are immediately evaluated and concrete values are returned, so it's now much faster now. So now let's see how we can declare variable inside TensorFlow. So in Python we can simply declare a variable. For example, here v0 is equal to 42, so it's a Python variable. But in order to declare a TensorFlow variable, use tf.variable and here inside parentheses specify the variable value. So I created that variable. So if you want to create an array, so you can simply use tf.variable and here inside parentheses you can specify the curly braces and specify the value the array should contain. Similarly, you can create multi-dimensional arrays as well. So if I run this line, now if let's check the variable v0, so value inside it is 42. But now let's check a TensorFlow variable. If I print it, you will see that a whole line is printed. Here tf.variable, it shows that it's a v1 is a TensorFlow variable and the shape of variable, then the data type is integer 32, it's a 32-bit integer. Similarly, the value is 42. So similarly, you can check the v2 and here you will see that it's also a TensorFlow variable and shape is 2. Now the data type is also integer and the value is an array which is 1 and 2. Similarly, you can check the v3, which is a 2D array. Now You can see the same things for this. Now its shape is 2 by 2 as it contains 2 rows and 2 columns. If you want to reassign a value, you can use simply variable.reassign dot assign function. v1 dot assign and 33. Now its value will be changed and it will become 33. Now let's look at TensorFlow constant. Like variables in other programming language, you can also specify constant inside TensorFlow. So in order to create a constant, use tf.constant function, and here inside parentheses you will specify the value. So if I run it, you will see that now it's not tf.variable, it's tf.tensor, which is used for constant, and its data type is integer 32-bit and the value is 42. Similarly, you can also specify this data type explicitly by using dtype parameter. So if I use tf.constant and the value is 62 and the data type is tf.float 64, now the data type of this constant will be 64-bit float. Now if I run it, you will see that now its data type is not integer 32-bit, but it's a float of 64 bits. Similarly, you can check the shape of a tensor. If I declare a tf.variable and I declare a 2D tensor, now if I run it, and tf.shape will return as the shape. So now its shape is 2 by 3 as it contains 2 rows and 3 columns. Similarly, if I print it, you will see the value inside. Now, after declaring and shaping a tensor, you can reshape a tensor like NumPy arrays. So if I want to reshape this 2 by 3 tensor into 1 into 6 tensor like 1D array, I can use tf.reshape function, and here the first parameter is the tensor you want to reshape and the second parameter is the new shape. So if I run it, now its shape is 1 by 6. So if I print it, now you can see it's not a 2D array, now it will become a 1D tensor. Now let's look at ranking of a tensor. The rank of tensor is the number of dimensions it has, that is the number of indices that are required to specify any particular element of that tensor. So for example, if we create a tensor T4, which is basically a two-dimensional array, now let's check its rank using tf.rank function, and here we will specify the parameter T4. Now if I run it, now you will see that its rank is printed here, NumPy is equal to 2. Its rank is 2 because it's a 2D array and we need 2 indices to get access to any particular element. Similarly, if we declare a 3D array, we need 3 indices, so the rank will be 3. So similarly, we can get access to any element of tensor using this square bracket method. So if we want to get element at the 0th row and the 0th column of tensor T4, we can simply use the square bracket method and store it inside T6. Now let's check T6. You will see that now the value stored inside T6 is 1. NumPy is equal to 1. So the value is stored inside T6 is 1 as the value of 0th row and the 0th column of T4 is 1. So now as you can see, it's giving us very unnecessary detail like tf.tensor, then data type, then finally it's giving us the value we want. So if you only want to get the value, you can simply cast it to a NumPy. So t6.numpy will only return us the value that is stored inside T6. Now you will see that it returned as 1. Similarly, for any operation, if you only want to get the value you are looking for, you can simply cast it to a NumPy. For example, if you can check the size of a tensor using tf.size function, and here inside the parameter input is equal to T4. Now if I run it, it will give me the size of this tensor, which is 6. As it's a 2D array, it contains 2 rows and 3 columns, so it contains total 6 elements, so its size is 6. But again, it's giving me very unnecessary detail, so I can simply cast it to a NumPy to get only the size. So if I run it, now you can see it only returned me 6. So 6 is the size of this tensor. Similarly, you can check the data type of a tensor using t6.dtype. Now it will give me the data type, which is integer 32, as the value stored inside T6 is integer. Now let's look at element-wise tensor operations. So firstly, we will create two tensor for variables T7 and T8. T7 contain an array which contain 1, 2. T8 contain an array that contain 2, 4. Now if we want to multiply these two element wise, we can simply use the multiplication operator. So if I run it, you will see that the result contains 2, 8, which we get by multiplying 1 with this 2 and 2 with this 4. So if we want to add these two tensors, we can simply use the plus operator. Similarly, for subtraction, use the subtraction operator, and division, use the division operator. Now if we want to multiply some tensor with a specific value. For example, if I want to multiply each value of t7 with 4, I can use this t7 into 4, and now if I print it, you will see that now it will multiply each value of t7 with 4. Firstly, initially t7 contained 1 comma 2, now it contains 4 comma 8. Similarly, we can multiply 2D arrays like matrix using tf.matmul function. So let's create our first constant. So tf.constant will create a constant which is a 2D array. Similarly, tf.constant will create another 2D array for s which is stored inside C2. Now if we want to multiply C1 and C2 like we multiply matrices using row column operation, so we can simply use tf.matmul function and pass C1 and C2 here. Now if I run it, you will see that now it multiplied each these two constants like we multiply matrices. Now similarly, you can change the data type of a constant by typecasting it. So firstly, let's look at C1. As you can see that its data type is integer 32-bit. Now if I want to change its data type, I can simply use tf.cast function, and here I will specify the new data type. So firstly, I specify the variable or constant whose data type I want to change. Secondly, I will specify the parameter d type, which is the new data type that will be assigned. So if I want to make it an integer 64-bit integer, I can use tf.int64. Now if I run it, you will see that now its data type is integer 64-bit. Similarly, you can declare rag tensors using TensorFlow. Rag tensors are tensors where the number each row contain different number of columns. Normally, we declare a 2D array or a matrix. Each row contain equal number of columns, but rag tensor contain unequal number of columns. So let's declare a rag tensor. So in order to declare a rag tensor, use tf.rag.constant, and here you will specify the elements of rag tensor. So here you will see that first row contain one element, second row does not contain any element, third row contain two elements. Similarly, the fourth row contain three elements. So the number of elements in each row are different. So that is a rag tensor. So if I print it, you will see that now it created a rag tensor for us, and its data type is tf.rag tensor. Now let's look at some of the TensorFlow operations. We will start by looking at how to find square difference between two tensors. So let's generate two tensors. So I created v1 using tf.variable, and it contained two values 3 and 4. Similarly, v2 contained two values 2, 2. Now if I want to get the square difference between these two arrays, I can use tf.math.squareDifference function, and here I will specify v1, v2. Now the third parameter is name. You can simply set it to none for now. Now if I run it, you will see that the result is 1, 4, which is the square difference between of these two arrays. So it actually subtracted this 2 from this 3, then taken the square, so we get 1 here. Similarly, it subtracted this 2 from this 4 and taken the square, so we get 4 here. Similarly, you can find the mean of a TensorFlow variable using tf.reduceMean function. So here, if I want to get the mean of v1, I can use tf.reduceMean, and here I will pass v1. So if I run it, you will see that the result is 3. Actually, the result is 3.5, but the default data type is integer 32, so it actually round it off and we get 3 here. Similarly, if you have a 2D array, then you can also specify the axis along which you want to find the mean. Like Python, if we want to get the value of certain function along row, I will specify the axis is equal to 1. Similarly, for columns, I will specify axis is equal to 0. So if you want to get the mean along columns, you will specify the axis is equal to 0. So let's create a 2D array using tf.variable, and we created this 2D array v3. Now if I want to get the mean along columns, I will use tf.reduceMean and pass the v3, and the axis is equal to 0. So if I run it, you can see the result is 2, 3, which is the result of mean along column. Similarly, if you want to get the mean along rows, you can use axis is equal to 1. Now if I run it, you will see that the result is 1, 3, which is the mean along rows. Now let's look at generating random values using TensorFlow. Random values are frequently required while developing neural networks. One way to generate random values is to use tf.random.normal function, and here you will specify the shape of the resultant variable. So if I want to generate a 2D array that contains 3 rows and 2 columns, I will specify the shape 3, 2. Similarly, you will specify the mean of the random values and the standard deviation and the data type of each value that is generated. tf.random.normal function will generate values which are normally distributed. So if I run it, you will see that the values are generated and the mean of all these values is 10 and the standard deviation is 2 and the data type is float 32. Similarly, another way to generate random values is to use tf.random.uniform function, and here you will specify the shape, the minimum value and the maximum value and the data type. So if I run it, you will see that now the random values are generated and the minimum value is 0 and the maximum value is 5, so all the values are between 0 and 5. So as you can see that no value is less than 0 and no value is greater than 5. Similarly, the data type is integer 32 as we specified. So as you can see that some values are repeating here, and if you want that no value be repeated, you can simply use the tf.random.setSeed and specify any random value here. Now if you run this line tf.random.uniform, all the values will be generated are distinct and no value will be repeated. So if I run it, you will see that no value is repeated now. Similarly, you can add two tensors using the plus operator as I told you earlier. So let's generate two tensors v1 and v2. So if I run v1 plus v2, you will see that it will add the values of these two TensorFlow variables element wise. Now the result is 3 plus 2 which is 5 and 4 plus 1 which is also 5. So the result is 5, 5. Similarly, you can concatenate two tensors using tf.concatenate function. So let's generate two TensorFlow variables. So I created first variable v1 which is a 2D array. Similarly, the v2 is also a 2D array. So if I want to concatenate it, I will simply use tf.concatenate and the values are v1, v2. So we are passing a list of values here. Similarly, you can pass v3, v4 by separating them with commas. And one more thing is the axis. So if you want to concatenate them along column wise, you will specify the axis is equal to 0. Similarly, for row wise, you will specify the axis is equal to 1. So if I run it, you will see that it concatenated it along column wise. Now the resultant value shape is 4, 2. So it contains 4 rows and 2 columns. Now if I run the same code by specifying axis is equal to 1, you will see that now the shape is 2, 4 as it concatenated it along row wise. So the resultant shape is 2, 4. It contains 2 rows and each row contains 4 values as you can see. Similarly, you can find the index of minimum value and the maximum value using the argmax function. So let's generate a v1 variable using tf.variable and it contains 4 values. Similarly, if you want to find the index of maximum value, you can use tf.argmax and here we pass the parameter v1. So and we cast it to NumPy to get only the index, not the unnecessary details. So if I run it, you will see that it returned me 3. So it is saying that the index of maximum value is 3. As you can see that the maximum value is 5 and it is present at the third index. Similarly, you can use tf.argmin to get the index of minimum value. So if I run it, you will see that it returned me 1. So the minimum value is 2 which is present at the index 1. So you can get the index of maximum value and the minimum value using the argmax and argmin function. Now let's look at saving and restoring tensor values using a checkpoint. You can use TensorFlow checkpoint to store the exact values of TensorFlow variables. Let's say you declare a TensorFlow variable and after performing some computations, the values stored inside that variable are meaningful for you and you want to save it to use it later. So you can use tf.checkpoint for that purpose. So let's declare a TensorFlow variable using tf.variable and we created a 2D array. And that array name is v1. Now using tf.range.checkpoint and here you will specify v1. Now using this checkpoint.save function you will save your TensorFlow variable and the name of the variable is my variable. So actually the dot and / is denoting our current working directory and it will store this variable v1 inside our current working directory with the name my variable. Now if I run it, now it stored my variable. Now let's print save path. So now the save path contain our current working directory, then my variable, then 1, as it contain create a separate name for each variable in the checkpoint stores. Now let's reassign a value to change the value of v1. So v1 dot assign, and here we will specify a new values for v1, and we will print v1 to see the values. Now you can see that the values inside v1 are changed and they are now 0. Now let's restore the original values of v1 we saved earlier inside v1. So using checkpoint.restore, and we will specify this save path to restore those values inside v1. So if I run it, now it restored those values inside v1. So if now I print v1, you will see that the values it contain are 1, 2 and 3, 4, which are the values we stored. So firstly we created a variable, then we saved its values using checkpoint, then we changed the values inside that variable, then we restored the original values from the saved location inside that variable. So using TensorFlow checkpoint, you can save your TensorFlow variables to use them later.
Welcome to this lecture. In this lecture, we will train our first machine learning model. Then we are going to generate a TF-Lite file for it, which will be used inside an Android application. So let's begin. So the first step is importing the library. So I'm going to import TensorFlow because we will use it to train our model. Then we will import NumPy because I'm going to use it for creating our dataset. Then from TensorFlow we will import Keras because we will generate our neural network model with the help of Keras. Then from TensorFlow we will import Lite because with the help of Lite we are going to convert our model into a TF-Lite format. Now the next step is creating our dataset. As it's a very simple example, so I created a very simple data set in which there are two variables. The first one is x, then the y, and the relationship between x and y is that each value of y is equal to 2x minus 1. So here y is the label and x is the feature. So here you can see that I created two array, np.array, and it contains values minus 1, 0, 1, 2, 3, 4 and so on. Similarly, y will contain other values, and relationship between x and y is that y is equal to 2x minus 1. So if the value of x is minus 1, then the value of y will be 2 into minus 1 minus 2 minus 1, which will be minus 3. So the value of y will be minus 3. Similarly, if x is equal to 0, the value of y will be minus 1. So you can clearly see that the pattern in our data. So the pattern in our data is y is equal to 2x minus 1. So we are going to train our machine learning model on the values of x and y, and we will see that whether our model will be able to extract that pattern or not. So that is our basic data set. X is the feature and y is the label, and we are going to train our model on this data set. Now the next step is creating our model. So I'm going to use Keras.sequential function, and it is quite useful library, Keras, because its syntax is quite similar to the actual structure of neural networks. In neural network we have an input layer, then we have several hidden layers, then we have an output layer. Similarly, in this Keras function we will have several hidden layers. Input and output layers are compulsory, so you don't need to specify them. So I'm going to use Keras.sequential here, and you will pass a list of hidden layers here, and you can create a hidden layer with the help of Keras.layers.dense. And here dense will create a hidden layer, and the dense layer is one in which each neuron is converted to the previous neuron. It's a fully connected layer, which means that each neuron of this layer is connected to each neuron of the previous layer. So I'm gonna use Keras.layer.dense function. Then we specified the number of neurons. So units is equal to 1 means that this hidden layer will contain only one neuron. Similarly, I use input shape is equal to 1, which means that the input shape of the previous or the output shape of previous layer is 1. So the output shape of previous layer is input shape for this layer. So the input shape for this layer will be 1 because we only have one feature x here. Similarly, I added a comma, then I specified a second layer, which is our second hidden layer. So Keras.layer.dense, and unit is equal to 1, which means that it also contains one neuron, and the input shape is also 1 because the output shape of previously hidden layer is also 1 because it also have only one neuron. So the input shape for this layer will also be 1. Now after creating our model, we need to compile our model, and here I specified two parameters. The first one is optimizer and the second one is loss function. Here loss function means that how much our predicted value differs from the actual value. As it's a supervised machine learning, so we have a label data. So after performing feed forwarding, we get a predicted result. Then we are going to compare this result with the actual result, and we will get a difference. So we want that the difference between predicted and actual result will be minimum. So we're gonna get this difference with the help of loss function. So we actually want to minimize this loss function. And here optimizer will help us to minimize the value of this loss function, as it contains the difference between actual value and the predicted value. So after we compiled our model, the next step is performing training. So we will use model.fit function and we will pass our data set. So we firstly pass our features, which is x, then we pass our label, which is y, then we specified a parameter epoch is equal to 500, which means that we want to train model on this data set for 500 times. It means that for 500 times feed forwarding and back propagation will be performed and our model will be trained. After training our model, we will test our model using model.predict function, and here we specified the value for which we want to test our model. As our model is training on one feature, so here I specified a single array with the value 10 that we want our model to return us the result for this value 10. So for this 10, result should be 2x minus 1, which is 2 into 10, 20 minus 1, 19. So the result should be nearby 19. So now let's run all the code here and check whether our model is accurate or not after training. So I'm gonna select all of them and press Ctrl plus Enter, and you will see that our model will be trained and we will get the result for this value 10. So the last print is the result for this value 10. So the result is 18.99, which is almost 19, and the actual result for 10 will be 2x minus 1, which will be 19. So our model is quite accurate, as the difference between actual and predicted value is quite minimum. So our model training is completed, and for 500 epoch our model is trained, and you can see that for each epoch the value of loss function is printed here. So when I move to the first epoch, so for now I'm at 370. So when I go further down, as I can't go further down, and I move to 253, and here you can see that the value of loss function is 10 minus 7. But when we move to the last or the 500 epoch, you will see that the value of loss function is 10 minus 12. So here you can see that the value of loss function is quite minimum at the end, which means that with each epoch our value of loss function is minimized, which is our main goal, to minimize the difference between actual value and the predicted value. So now our model is trained and we tested our model. Now the next step is saving our model. So in order to save our model, we will firstly save it in a keras format. So here I use tf.keras.model.savedModel function. Then I specified the model we want to save. Then we specified the file name, which will be linear.h5. The saving format for keras model is .h5 file. So we specify linear.h5 here. So when we run this line, our model will be saved in keras format. Now the next step is saving the model in tf-lite format. So we are going to use this Lite object. So Lite.tf-lite converter from keras model, and we will specify our model here. So we will create a converter object here. Then we will use converter.convert to convert this model into a tf-lite format. Then we will finally open linear.tf-lite file in a binary writing mode, and we will write this tf-lite model here as we seen in the file handling section. So when we run this line, you will see that the both files, linear.h5 file or linear.tf-lite file, will be created. So now let's run them. So these lines are also compiled successfully. So now let's check that whether these files are created or not, and these files will be saved at a location that you specified here. So I specified basic example course function here. So my files will be saved in that folder. Similarly, you can change the folder here by clicking on it. But for now I'm gonna keep it safe, and when I'm gonna open this basic example course function, you will see that I have both files, which is linear.h5 file and linear.tf-lite, and these files are generated at 3:24 AM, which is the same time I run that code. So we trained our model, tested it, and created a tf-lite file for it. Now the next step is creating an Android application for this model, and we are gonna do it inside next lecture.
Welcome to this lecture. In this lecture, we will build our first Android application using the model we trained in the previous lecture. So let's begin. So I created a simple Android Studio project and I already created the GUI of the application. So when I open activity main.xml, here you will see that I have a simple edit text here, then a button, then the result text view. So in this edit text, user will enter the value of x, and upon clicking on this predict button, the value entered here will be taken and it will be passed to the model, and the result returned by model will be shown in this result TV. So hopefully you will get the idea that how our application look like. So now let's look at the main activity code. So here you can see that I initialize the GUI elements. So firstly I created edit text, then a text view, then a button. Then I initialize them, and here I set a listener on the button. So when the user will click the button, the text entered inside this edit text will be taken and it will be passed to the model. So now let's begin by adding the dependencies for TensorFlow Lite. So open the code.txt file given in this lecture resources and copy this line implementation org.tensorflow Lite. And now you need to open your build.gradle file, and here you need to paste it so the library TensorFlow Lite will be downloaded. Now you need to add some more things, and these 4 lines also be added inside build.gradle file. So I'm gonna copy them and I'm gonna paste it here just before the closing of our Android tag. So these lines are specifying that our tf-lite file should not be compressed like other files. So now click on the sync now, so the libraries are downloaded and the changes are saved. Now you will see that our Gradle will be built in a moment. So our Gradle is built successfully. Now the next step is adding our trained model inside Android application. So we will put this model inside assets folder. So just right click on this app folder, and here you need to click on this new section and then go to this folder section, and here you need to select assets folder. So just click on it, and when you press finish button, asset folder will be created. I have already created it. So here you can see that asset folder is already present. So I'm gonna copy my linear.tf-lite file and I'm gonna paste it here. So I'm gonna copy this file and I'm gonna paste it inside my asset folder. So your model should be placed inside the asset folder. So I pasted it here. Now we need to write the code for using this model for prediction. So you need to open this code.txt file again, and here you can see that there are 2 methods. So firstly I'm gonna copy this method map_byte_buffer.load model file. So I'm gonna copy it and I am gonna paste it here just below my own create method of our main activity. So I'm gonna paste it here, and then I'm gonna add the imports. So press Alt plus enter and the imports will be added. So I will add the import for other libraries as well, and similarly for file channel. And now all the imports are added. So what does this function will do? It will gonna open this linear.tf-lite file and it will gonna return us this model linear.tf-lite file in a format called mapped_byte_buffer. Mapped_byte_buffer is an optimized format which will help us to increase the efficiency and speed. So now I pasted this method. So now let's copy the other method as well. So I'm gonna copy this doInference method, then we will look at the code inside this method. So I'm gonna copy it and I'm gonna paste it just below this mapped_byte_buffer method or load model file method. So I pasted it here. So here you can see that it is using an interpreter variable. So firstly we will create an interpreter, then I'm gonna explain the code in this doInference method. So in order to load the model and get prediction from it, you need to create an instance of TensorFlow Lite interpreter. So I'm gonna create an interpreter here. So interpreter, and then I'm gonna name it interpreter, and here I'm gonna initialize it inside my own create method. So interpreter is equal to new interpreter, and this interpreter will gonna take a map_byte_buffer. So I'm gonna use this load model file method that is returning a map_byte_buffer. Then the second parameter is interpreter options. So we don't want to specify any options, because if you want to customize the interpreter, then you will use interpreter options. But for now things are quite simple, so I'm gonna pass null here. So here you can see that it's throwing an exception, so I'm gonna surround it with try catch. So now you can see that we created an instance of interpreter, and now let's look at the code inside doInference method. So here doInference method is taking the string, which is actually the text user entered inside the edit tag. After taking that string, it will gonna create an input array, because during the model testing or during the model evaluation you have seen that when we tested our model, we passed the value 10 inside curly braces, which means that we passed an array of type float. So I created an input array of type float and I passed the value user entered inside edit text. So I firstly converted the value into float. So using float.parseFloat will return us a float value and we put it at index 0. Now I created another array which is output array, and it's a 2D array. It only contains one row and one column, which means that it will contain only one value, which will be the output. And using interpreter.run method, we passed our input array and the output array. So interpreter will actually gonna take the input entered here, then it will gonna get the prediction for that input and it will gonna place the result inside this output array. So we will return the value placed at the 0th row and the 0th column of this output array, which is our result. So this do inference method is taking the string value which user entered. For example, if I enter 10 here, then it will gonna take this 10, then it will gonna return us the result that our model predicted. So I'm gonna use the do inference method here inside my predict.setOnClick method. So here I'm gonna call this do inference method. So do inference, and I'm gonna pass the edit text dot get text dot toStrings. So the value that user entered inside this edit text will be passed to this do inference method, and it's returning a float variable. So I'm gonna name it float f, and now the result will be stored inside this f variable, and we need to show this result inside our result tv. I'm gonna use result tv dot set text, and here I'm gonna pass firstly result is equal to or result, and then I'm gonna pass this float value. So now our application coding is complete, and I'm gonna repeat the whole process here. So the first step is you need to add the dependencies. So firstly you will add the dependencies so that the TensorFlow Lite library will be downloaded. After that you will specify that the tf-lite file should not be compressed. Then you will create an asset folder and put your model.tf-lite file here. Now the next step is creating an interpreter object. So you will create an interpreter. So interpreter is equal to new interpreter. Then you will load your model and convert it into a map byte buffer using this load model file method. So I wrote it here so you can see that we loaded our model, then we returned in the form of map byte buffer. So interpreter will gonna take it, and then you specify interpreter options. After that you need to run the inference, or you want to get the prediction. So you will use this do inference method, and here it's actually firstly creating an input array where the input value will be placed. Then we created an output array in which the output value will be placed by our interpreter. Then we pass both of these values to this interpreter. Then we showed the result inside our result tv. So that's the whole process. So now let's run our application and test it. So now our application is installed successfully. So now let's test it. So I'm going to enter a value 10 here. Now I'm going to press this predict button, and we will check the result that our model returned. So when I press this predict button, you will see that the result is 18.98, which is almost 19. As the pattern is y is equal to 2x minus 1, so 2 into 10, 20 minus 1, 19. So our result is quite accurate. Similarly, you can test it for 100. So I'm gonna add 100, then I'm gonna press the predict button again, and you will see that the value is 198.82, which is almost 199. So our application is working quite well, and our model accuracy is quite high. So hopefully you will get the idea that how you can train a machine learning model and develop Android application for it. As we used a very simple example, so this will give you the idea that how machine learning models are used inside Android application. And in the upcoming lectures, we will move from basic to advanced stuff. So see you in the next lecture.
For learning more about TensorFlow Lite use in Android with advanced example, kindly visit the course page at Udemy. Link is given in the description.